data booklet, the equations that we are going to involve is the use of acidified potassium permanganate, MnO4 minus plus 8H plus 5 electrons to give us Mn2 plus 4 water. And this one from your data booklet is an E theta value of plus 1.52. And then your iron 2 will be oxidized to iron 3, Fe2 plus, forming iron 3 plus an electron. The E theta value for this equation is minus 0.77. These ones I'm getting from the data booklet. Now, your potassium permanganate is deep purple. It's purple colored. And then your manganese 2 plus is colorless. So for this particular titration, we don't need an indicator. Then, as you add your potassium permanganate to iron 2, it should be decolorized, forming manganese 2 plus, because if you add the E theta values for these two half equations, you are going to get a positive value. That means the reaction is feasible. Now, your sulfuric acid that you are going to use in the acidification of potassium permanganate is your Fa3, and your potassium permanganate is your Fa2. Then your iron salt is what has been provided as Fa1. The purpose of this practical is to determine the molecular mass of your iron 2 salt. You are given that iron 2 salt and then asked to make a solution. From that solution in the stoichiometric equation, you are to determine the molecular formula of your iron 2 salt. And how are we going to do that? Let's consider that question on the board. Our practical is similar to that question, but it's a different question, but they use the same principle. Iron 2 sulfate crystals with the following formula. We are given the formula in an experiment to determine N. 8.492 of the salt were dissolved and made up to 250 with distilled water and dilute sulfuric acid. A 25 cubic centimeter portion of the solution was further acidified and titrated against potassium manganate 7 solution of concentration 0.15 molar. A volume of 22.5 was required. Let's try to work out that question before we do the practical. Now, these are our half equations. Let's add them and get an overall equation. Let's balance here so that our electrons will cancel out. So here I'll add 5. Then MnO4 minus plus 8H plus 5 Fe2 plus. This one will form Mn2 plus 5 Fe2 plus 4 H2O. And the E theta value, can somebody calculate? It's 1.52 minus 0.77, which is 0.75. So this equation, this reaction, since the E cell is close to 0.75, which is positive, it's feasible. Now, can you touch the mouse? And then scroll up. Use the arrows. Now, for this particular question, we are given that the amount of manganate, of potassium permanganate that we used, M potassium permanganate, KMnO4, is equals to 8.492 grams. 8.492 grams. And then from that question, we are told that for the complete reaction, we required 22.5 cubic centimeters of what? Of potassium permanganate. From that concentration and the volume, we can get the number of moles of potassium permanganate. Therefore, N MnO4 minus required for this particular reaction is equals to concentration, which is 22.5 over 1000 cubic decimeters, times the concentration. What is the concentration? 0.015 moles per dm cubed. 0.015 moles per dm cubed. Can somebody calculate the number of moles of KMnO4 from that? From your concentration and your volume? This 3.75. Okay, these are the number of moles of potential per manganese that were in 25 cubic centimeters that was used for the titration. From that, let's use a stoichiometric equation to determine the number of moles of your iron 2 salt, or the number of moles of your iron 2 plus that reacted with that number of moles of your KMnO4. We multiply by 5. Therefore, NFe2 plus equals to
0.00168.
0.0016. Okay, let's express to 3 significant figures, which is 9. Okay, so in our solution, for 25 cubic centimeters of our solution that we use for the reaction, there was 0.00169 moles of Fe2 plus. We agree? Now, our iron 2 salt was not dissolved in 25, but it was dissolved in 250. So let's calculate the number of moles of iron 2 that were in 250 cubic centimeters. Number of moles of iron 2 that were in 250 cubic centimeters. If in 25 cubic centimeters we had this, therefore NFe2 plus now in 250 equals to 250 over 25 times 0.00169. What's the answer?
0.0169.
0.0169. Those are the number of moles of our iron 2 salt that were in 250 cubic centimeters. That means we took our iron 2 salt and dissolved it in 250 of sulfuric acid and your water. That sulfuric acid is the one that we use to acidify our equation for potassium permanganate. Now we have the number of moles in 250, and we also have the mass in 250. From that we can calculate the relative molecular mass. Okay, our formula mass Mr is equals to number of mass over N. Let's calculate the molecular mass. We are given the mass as 8.492 grams, and the number of moles in 250 we have calculated to this. What's the molecular mass?
502,
5 grams. Let's just round it to 503 grams. So our iron 2 salt, which is the ammonium iron 2 salt, had an MR of 503 grams. But the formula for that from what we've been given is NH4 by 2. Then FeSO4 dot A, which is our non-A, then H2O. We are to determine the formula, the value of A. Okay, let's add the masses. using the relative atomic masses. Nitrogen 14, hydrogen 1, iron use 56 from the data booklet. You'll be given those in your question paper. Iron use 56, use 55.8 for iron, and then for sulfur use 32.1, for oxygen use 16, nitrogen use 14,
Please repeat.
iron 55.8, nitrogen 14, sulfur 32.1, oxygen 16. 181. For this portion, it's 18 times 2. That's 36. 36 plus 55.8 plus 32.1 plus 64. Okay. 180. 187.9 plus 18 by A plus 18 times A. This would give us the total molecular formula. Then what would be the value of A? What would be the value of A from the equation? 187.9 plus 18A equals to 503. 10.4. It's 10.4. Can I have the calculator? 36 plus 65.8 plus 32.1 plus 64 plus 18A is equals to. Then this one from 543 is 315. Then we divide by 18. 17.5. So from that calculation, your A is equal to 17.5, which is 18. But there's somewhere where we made a mistake in the calculation. That value should be 12. That's A. It should be 12. Okay, but do you understand the principle that we used?
Yes.
Yeah, so that's the practical that you are going to do. You are to determine using titration the molecular formula of your iron 2. So now you are not given this. You are not given this formula. You are to determine that formula from titration. So you are going to find the number of moles. The number of moles converts to MR. Then from the MR, you can then determine the formula. Okay, let's look at our question paper. It's from June 2013, paper 3.3. Fa1 is iron 2 salt, and Fa2 is 0.02 molar potassium permanganate, which is our source of our MnO4 minus. And then Fa3 is dilute sulfuric acid. Now, how are we going to recognize our endpoint? Let me have, this is our Fa2. Now can somebody give me this to the water? This beaker, you're not the one, it's not the one you are using.
So is that Fa2?
Yes, this is your Fa2, your potassium permanganate. Yes, this is your Fa2.
Yeah.
It's colored and it's deep purple. Now, how are we going to identify our endpoint? Since this one is colored, we don't need an endpoint. So our endpoint, we are going to identify it by the appearance of a permanent pink color. Let's focus here. This is water. Now our endpoint, as long as there's some Fe2 plus and we add MnO4 minus, is going to react and you are going to produce a colorless solution. But if all the Fe2 plus have been used up, you've reacted in the reaction. If you add more MnO4 minus, a single drop is going to produce a permanent pink color, because if you disperse your deep purple, you produce this permanent pink color. So this is going to be our end point of the reaction. Okay, we may start the practical.
Make sure the volume of water you measure using a measuring cylinder. Don't use a beaker, it's natural. Use a measuring cylinder provided. Measure your Fx first.
dissolving. After dissolving, make up the volume 250. Make up the volume 250, the volumetric flask. Then start the titration as instructed. Don't overshoot the mark in your volumetric flask.
after filling your burette with FA3, allow some to run out first before you begin the actual titration. Allow some of the FA3 to run out from your burette before you do the actual titration. FA2. If you pay it as 25. If you pay it as 25. But 25 in. Allow some to run inside the session. This is what 25 that you pay it. And it is this. As long as it's dissolved in peace, then the end point is not being reached. So this can be a rough tight. And then from that, then do 3 more accurate tighters. Which column is best? Then read your mark and start the tighter. First, do a rough tight. Join another book. Join me. What's your waist? 8.
See, I'm sure.
Let's go. No, don't do zero mark, just some way you can do it. What's the reason? It's not good. Start from 0.2. Start from 0.2, not your initial direction, it's 0.2. Let's do a rough tighter first. Initial is 0.2. Then do a rough tighter. Control continuously. Shake switch roll. You're nearing the 8. Then continue until you get a feminine peak time.
That's your upside. That means your input should be around 30 or something. 36 your endpoint.
Yeah, but I close it.
Your rough tight.
Yeah.
Now do an accurate tight.
Okay.
Around start controlling it around 30.
Okay.
Let's see. Are you making progress? What's your rough tight? Now 3 more accurate tight. What's your update? What's your update? So make sure that you get around 20, start controlling care. If you don't want it. Yes, about 3 that are accurate. 3 accurate sighters. Don't overshoot the end points. Don't overshoot. Do the next sighter. The next sighter. One to the calculator. You do them on rough. What's the value? Around 10. Do 3 more that are accurate. How many do them? Yes, but much your own 5. 3 more accurate.
I'm still going to add the tent.
Yes, you are repeating the
3
same
more
thing.
that are accurate. You do not have the initial value. Close.
Check from there. Then you tell me. I just wait initials here. Controller, right?
Control.
Yes.
Make sure as you reach the end point, you do drop twice. Don't overshoot.
Yes. Perfect.
You added 1 extra drop, but it's accurate.
So it's a much bit. 25, 24.
The rough title was what? What was your rough title?
It was 36. Even my rough title was 24. But I told you, see that I made it. My rough title was 24. So, you need to do this. This is not this. Okay, so rotate it.
Just rid of that.
So this one is essential is what? Should be able to zero. Why should it Yes.
So do you record it? You put 2 decimal places.
After 2 decimal places.
The difference between the first one and the second one.
That one was 26. Then the accurate one is 28.
The rough title was 27. Then you are supposed to do 3 accurate titles. This is 2 things. Deep cut. You've red overshot the end point. It should be faint pink. Just one drop will change the color if you are accurate. Do it again and do it accurately. As you get to the end point, clockwise.
Which one? But with this one as well.
You know what? It was going to be fine. Yeah, perfect.
It's not.
That's okay.
No, it's actually good. It's good. No, it's proper. It's okay. It's really good. That's what it is.
Cut corners. Yes. Record that accurate. Avoid the parallel square. It's 20. It's 3.9. Stronger end for shaking, weaker end for opening. Your stronger end should be used to shake and your weaker end. You are right-handed.
Yes, I'm right-handed.
Then your right hand should be used to shake. And then your left to
We're supposed to add
FA3. Before adding that, you do add FA3 25, 20 cubic centimeters. Add FA3 20 cubic centimeters.
That's fine. It's just a chicken.
I'm coming. Do it clockwise. Don't act like you are pouring into something. Do it clockwise. Okay, this is your faint color that I'm expecting at your end point. It should be faint, not dark. This is the faint color that I'm expecting for the end point. If you see it darkening, it means you've already overshot the end point. If you compare these two colors, this one is inaccurate, this one is more accurate.
So
Okay, let's do the calculations. Let's do the calculations. Let's do the calculations. If you have if you just have two values that are within 0.1 cubic centimeter of each other, use those for your accurate calculations. Two values within 0.1 cubic centimeter of each other are accurate.
They kind of follow which are four.
Okay, let's do the calculation. Let's do the calculations now. The first part, let's go to C. Calculate the number of moles of potassium permanganate 7 present in the volume of Fa2 calculated in B. Get an average volume, but use only those values that are within 0.1 cubic centimeter of each other. Don't use any value that has a deviation of 1 cubic centimeter from the others. Then if you have 3 of those, get an average and use that as your volume. Now use that volume and the concentration to calculate the number of moles. You have volume, you have the concentration. Calculate the number of moles. Concentration equals to number of moles over volume. Now you have the volume and the concentration. Make n the subject and calculate. Make sure your volume is in cubic decimeters, not in cubic centimeters.
That's the table. The second bit.
Yes.
It's 25.
like average flow.
Where is my ruler? You have it. My place is my ruler.
Are you taking photos?
My initial is definitely
You want the calculations. What's your volume? This is the number of moles. The one you use for the three. So why did you write on the one that is supposed to be Yes, let's say your volume. Let's say your volume. Let's say. Come on. Write the average volume. And then use that to calculate the number of moles. Let's say. Yes. That's the calculate value of. That's the calculate number of moles of iron. Use first obtain an overall equation for part 3. Question item 3. First calculate, write the overall equation by adding the two half equations. There were one for potassium permanganate, the one for iron 2. Then from that use stoichiometry. You have the number of moles of manganese from your titration. Use the stoichiometric ratio to obtain the number of moles of iron 2 in 25 cubic centimeters. Then remember, those are in 25 cubic centimeters, but we dissolved ours in 250. N, number of moles of MnO4 minus is equals to the concentration of your NMO4 minus times the volume that you use, which is your titer value, your average titer value, which I can say is X, but it was in cubic centimeters, so we convert it to cubic decimeters by dividing by 1000. For example, which value did you obtain as your accurate titer value? 24.45. This one is their titer value, and then this is our conversion to cubic decimeters. Then we get the number of moles of MnO4, but we have this half equation, MnO4 minus plus 8H plus 5 electrons to get Mn2 plus 4 H2O. We also have this one, Fe2 plus form Fe3 plus an electron. Now to cancel, so that our electrons can cancel out, we balance by adding 5. And then our overall equation for the process, our overall equation will be obtained by adding 1 and 2, which is MnO4 minus plus HH plus 5 Fe2 plus, this one will produce Mn2 plus 5 Fe3 plus 4 H2O. Now from that we have 25 cubic centimeters of MnO4, and from that we calculate the number of moles. What is the value from your calculation? 0.00489. Okay, 489. These are the number of moles of MnO4 minus. Now we want the number of moles of Fe2 plus. We just use the stoichiometric ratio of 1:5 multiplied by 5. By 5, then by 10. And note, this one multiplied by 5 gives us the number of moles of Fe2 plus in 25 cubic centimeters. But the question requires us to know the number of moles in 250, so we multiply eventually by 10.
I'm so sorry. It's fine. There's no space for that.
So on item 4, you multiply your number of moles of Fe2 by 10.
Then you get this. This right there, 0.02.
Calculate the number of moles. What?
Of iron.
We're supposed in 250, so we weren't supposed to multiply by 10.
It's by 10, yeah.
So it's 0.0.
It's still 0.02.
That doesn't make any sense. Oh wait, that makes sense. No, it doesn't.
By 5.
Yes, and then by 10.
No, for this one is the one that will multiply. These ones were in 25. Now here we are being asked the number of moles in 250.
So you multiply this by
So we multiply this one by 10, which brings us to 0.2. You got it? Here, the number of moles of iron 2 plus were in 25 cubic centimeters.
But you did not use 25.
You use the 25. It's the one that you pipetted. You pipetted how much? Using the pipette. 25 is this one. Now, here you multiply by 10 because that whole iron was dissolved in this 250.
one mole of iron 2 cells. Okay, 1 and there is 1 mole of iron.
Must we use this 9.7 grams?
It's the same thing.
9.7 grams.
Yeah.
No. In 1 mole of iron 2 cells, there's 1 mole of iron 2. Use the mass of this. You weigh it out to calculate the amount of It's weight. Okay, it's molecular MR is supposed to be our mass is 9.7. The average, yes. I think that's where the problem is. Over the more you got in the previous part.
So then our mass is what? It's not 9.7.
It's not 9.7, that's the problem.
Can't we say it individually?
134.2.
Yes, which was the mass of the beaker and the FA1.
No, we're using the contents, not the what the
9.7.
yeah. It said just say that.
Okay.
But it's way over.
It's late. You better mind that. No, better mind that.
No, that's 8.8. 9.7
Better
divided
one.
by 7.
Better one. Can I have?
Yeah, it's still 8.8. And the container same calculate the maximum percentage error the
Which one? One more iron salt. And then there's one more. Isn't it that relative formula?
Wait, what do they mean percentage error in measuring a favor?
Yeah, but we're getting a decimal.
Is it not supposed to be F plus plus or minus?
which one of the
We got 0.024 for iron salt.
Percentage error plus or minus 0.1.
And listen, there's in the iron salt there is 1 mole of iron 2
Plus or
and
minus.
use the most of it.
then the one is over what?
This one is 1 is to 1. It's the same as whatever. But we're getting 1 more than these are your number of ions. Calculate the moles of ions present in 250. You multiply by 10. And 1 mole of iron to salt Fa1 is 1 mole of ions. Use the mass of Fa1 you weigh to carry out. And it's supposed to be like this.
Yeah, no. We used the last one.
No, wait, it is like this.
He's noted.
The percentage.
They're not very just in a percentage error. Percentage error.
Yes, just
Percentage error.
Where did you get your mark?
this one is 0.02, not 0.2. Concept. Can you see? We have not yet. Use or a big volume which charge a value of it. Then get an average and then use it in the calculations. Slight deviation from that of
But it's fine.
yeah, you can leave it.
Are we doing this one?
Alright, what did you use to measure your FA4? Yes, what did you use? What did you use to measure FA4 that you used in the .1 over your actual value of FA. 0.1 over your actual value of FA. Yes, that's a minus 0.1 over your actual value of FA. Alright, calculate. This is the solution. That's the sum. Calculate the MR. Here we have suffix 32.1 plus 64 is that 96. 94 is that. Then plus 55.8 plus 55.8 and those were what? Plus 36. This is 476 and you're 485. Here we have two sulfates.
Did you put there's 2 irons?
the molecular formula of your iron 2 salt, the ones that I gave you, is NH4. This one by 2. Then FeSO4. Again, this one by 2. Dot 6H2O. Then from that calculate and compare your value of the molecular formula that you got to that one. Your molecular mass to the molecular mass from that addition.
This is remarkable information.
Nitrogen is how much?
Nitrogen is 14.
Oxygen is 30. Iron.
Iron is how much? Iron is what?
Okay, I think everyone is now done. Let's end it here today, then we will finish the calculations later. Thank you everyone, and do share with those who are not here. And then that question is your assignment. That question that I gave you is the same principle that you used in the calculation for this one, but you did it practically. So you can be asked this question as a practical, or you can be given this in a paper to paper, and then you should be able to perform the calculation with no hassle. Thank you all.